Welcome to lecture on transformers. In machine learning, every couple of years somebody invents something new and crazy which will make us consider all the previous understanding and enable us to envision stuff what was previously considered impossible. What we are looking at today is something called transformers. Why transformers are important and where they are used. Transformers are models which can translate text, write poems and articles and generate computer code. As you may be already aware, many transformers are trained on a variety of machine learning models. Examples of transformers: language model for dialogue applications, Lambda, and pathways language model, PaLM, which are a Google-trained language model, GPT3 and GPT4 language models which are trained by OpenAI. Until transformers, we used to understand text with help of neural network which was termed as recurrent neural networks or RNN, which is as represented in the diagram on your screen, to translate a sentence from English to French. RNN will take an English sentence as input and process each word one by one sequentially and convert them to corresponding French word. In language, order of words matters, and we cannot justify them around. Limitation of RNN are: if you have a very large sentence, it cannot get the information at the start of sentence or what the context was or the intended meaning. Since it's done sequentially, RNN does not support parallelization. The memory and inability to process data in parallel are the two limitations of RNN. Now let's look at an example which would make RNN concept we discussed even clearer. Jane went looking for trouble and trouble went looking for Jane, completely two different sentences with different meaning, which implies they are not correct, meaning any model which deals with sentences has to capture correct word order. Since RNN does look at each of word sequentially, we can infer two major known issues with RNN. When we have very large sequences of words, text, paragraphs, or even an essay, by the time RNN processes the entire text in an essay or paragraph, due to limited memory by RNN forgets actual meaning of text at the beginning. So the context of this paragraph and sequence of text and its intended meaning may be lost. Since RNN processes sequentially and cannot parallelize are two known limitations we discussed in previous slide. Transformers were introduced in 2017 by a team at Google Brain, and its initial purpose was to deal with translations. Unlike recurrent neural network or RNN, transformers can be parallelized with use of right hardware, like graphics processing unit, GPU, or tensor processing unit, TPU. We can train large data models in finite time in comparison to recurrent neural network. In layman terms, we can assume combine a which scales well with massive data set, and the results will blow your mind, which are what transformers are. In the figure on screen, we can see all components of a transformer. But the three major ones we should know are: positional encoding, attention, self-attention, which are also termed as three main innovations which enable transformers to work really well. Positional encoding describes the location or position of an entity in a sequence so that each position is assigned a unique representation. There are many reasons why a single number, such as the index value, is not used to represent an item's position in transformer models. For long sequences, the indices can grow large in magnitude. If you normalize the index value to lie between 0 and 1, it can create problems for variable length sequences as they would be normalized differently. Let's look at text translation we discussed earlier. Instead of looking at each word sequentially, instead look at each word in a sentence and before feeding data to neural networks, slap it with a number depending on what number word it is in sentence and save info of word order in data itself. When you train network with lots of text data, and model also learns to interpret positional encodings in a way neural network learns importance of word order from data. This is high-level understanding of positional encoding. Let's look at concept of attention in transformers. Attention refers to the ability of a transformer model to attend to different parts of another sequence when making predictions. This is often used in encoder-decoder architectures, where the encoder vectorizes the input sequence and the decoder attends to the encoded representation of the whole input when making predictions. In the example on screen, imagine trying to translate an English sentence to French. One terrible way of doing it is trying to convert each word in sentence to intended language. Why this does not work in French? Some words are flipped. European comes before economic, and attention mechanism is a neural network structural mechanism which allows text model to look at every single word organized in original sentence when making a decision on how to translate word in open sentence. To simplify further, assume this as a heat map for attention. Let's look at concept of self-attention in transformers. Self-attention, on the other hand, refers to the ability of a transformer model to attend to different parts of the input sequence when making predictions. The name comes from the fact that contrary to regular attention, self-attention refers to the same sequence which is currently being encoded. The breakthrough is similar to attention's one. Back in recurrent architectures, the encoder had to compress all information that was needed further down the line in a set of vectors which were passed around by the recurrent cells. You might already see where this is going. This setup was also prone to forgetting some facts if the window of information was too large. Self-attention allows us to look at the whole context of our sequence while encoding each of the input elements. No forgetting of information will occur here, because our window of retaining information is exactly as large as we need it to be, at least in the base version of the self-attention. Let's look at example in slide by looking at the context of surrounding words. Self-attention helps neural network understand word in context and word around it. Server, can I have a check? Is diametrically opposite from looks like I crashed the server despite actors in both being server. If you understand the context and if you are trained on it, you can make better inference. This wraps up lecture on what are transformers and its important concepts. For a quick recap, we learned recurrent neural network or RNN, limitations of RNN which are memory and parallelization. Then we learn what are transformers and how they can be effective in parallel with use of right hardware like GPU. We can train large data models in finite time when compared to RNN. 3 important concepts of transformers. Positional encoding describes the location or position of an entity in a sequence so that each position is assigned a unique representation. Attention refers to the ability of a transformer model to attend to different parts of another sequence when making predictions. Self-attention, on the other hand, refers to the ability of a transformer model to attend to different parts of the input sequence when making predictions. Thanks for watching the lecture and hope you liked it.